Okay, class, today we're in section 14.2. Section 14.2, trend lines and predictions. Trend lines and predictions. Essential question: how can you use a trend line to make a prediction from a scatter plot? How can you use a trend line to make a prediction from a scatter plot? Get the lesson title or the section title in your notes along with this essential question. Okay, let's take a look at example 1. Finding the equation of a trend line. You can use 2 points on a trend line to write an equation in slope-intercept form for the trend line. Example 1. The scatter plot and trend line show the relationship between the number of chapters and the total number of pages for several books. Write an equation for the trend line. All right, let's take a closer look at the graph. Notice that the chapters are on the x-axis and the pages are on the y-axis. So what that means is they plotted these particular points for x and y. They plotted each one of these points for x and y. Then they drew the trend line. And the trend line is drawn in such a way, now make sure you're paying attention because you're going to need to do this. The trend line is drawn in such a way that you have about the same number of points above the line as you do below the line. About the same number of points above the line as you do below the line. Trying to make sure that you get at least 2 points on the trend line. Trying to make sure that you get at least 2 points here and here on the trend line. We're now take a real close look at the number of points above the trend line. 1, 2, 3, and 4. And take a look at how many points are below the trend line. 1, 2, 3, 4. Now that's what you're trying to do after you graph your data. You're trying to get this line in such a way that you have the same number of points above the line as you do below the line, while making sure that you have at least 2 points on the line. Now sometimes you may have one more above or one more below. Doesn't matter, so long as it's really, really close to the data. Okay, now after you've made your graph and you plotted your points and you drawn your trend line, then you go to step 1. Find the slope of the trend line. The line passes through the points 5 and 50. That means x is 5, y is 50. 17 and 170. That means x is 17 and y is 170. We're going to use the slope formula. M is equal to y2 minus y1 over x2 minus x1. Okay, once again, we're going to use the slope formula. M is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. All right, and notice here is 5, x is 5, and right there is 50, y is 50. X is 5, y is 50. That's that point. All right, next we have 17. See 18 right there? So that means 17 is going to be about right in the middle there. So there's 17, and y is 170. So that's that point right there. All right, so those are the 2 points we're using to find the slope. Okay, now after labeling our points, x1, y1, x2, y2, and once again, we label so we don't get confused when we plug it into our equation. Now all of this should be a repeat from what we've done early in the year when working with linear equations. So we're going to plug in. My y2 value is 170. That's why they put 170 right there. My y1 value is 50. So in place of y1, we put 50. My x2 value is 17. So in place of x2, we put 17. My x1 value is 5. So in place of x1, we put 5. Now we do our basic arithmetic. 170 minus 50 is 120. 17 minus 5 is 12. 120 divided by 12 is 10. So we find then that our slope was equal to 10. Now that we know our slope is equal to 10, we're going to go to step 2. Find the y-intercept of the trend line. So we're going to use our slope-intercept form equation. Y equals mx plus b. Y equals mx plus b. So what we do is we take one of the values up here, one of the coordinates, 5 or 50, or 17 or 170. It doesn't matter which one we take. Most of the time you take the one that's easier to work. So the smaller numbers here are 5 and 50. So we got y is equal to mx plus b. What's the y value? 50. Is equal to m. We found m to be 10. What's the x value? 5. And we don't know the y-intercept, so we say plus b. So now we get 50 is equal to, what's 10 times 5? 50. Plus b. Now we're going to solve this for b. And we solve this for b by getting rid of this 50. It's a positive 50, so therefore we subtract 50 from each side. What we do to one side of the equation, we must do the same thing to the other. After doing so, we find that 50 minus 50 is 0. So we just left with just b. 50 minus 50 is 0, so this cancels out. And we're left with just b. On this side, we got 50 minus 50, and that's going to be equal to 0. Remember, just in case you're confused, 50 minus 50 is 0, but then 0 plus b is equal to b. Over here is just simply 50 minus 50. So 50 minus 50 is 0. So we find then that our y-intercept is going to be equal to 0. Remember now, b stands for the y-intercept. All right, so our final step, step 3, we used the slope and the y-intercept values to write the equation. So y equals mx plus b in this case. Y is equal to 10x plus 0. The equation for the trend line is y is equal to 10x. In other words, when it's 0, you don't have to write it. Now, you could have concluded that the y-intercept was 0 from the graph. You could have made that conclusion from the graph. See how the y-intercept here is 0? Right. Also, notice the x-intercept is also 0. But don't forget, on FSA, they're going to make you prove it. They're going to make you prove how this is 0 through algebraic manipulation.
Let's take a look at another data set where we look at people and the years of experience and then graph the years of experience against their current salaries. So, for example, here you see that here's a person that has no years of experience. His initial salary is around $30,000 or maybe $31,000. These units are in thousands of dollars, and so forth. So you can see exactly what this data shows, and you can see there seems to be a trend, right? This line seems to be a line, it seems to be linear first of all, and it seems to be kind of heading up. So it looks like there's positive correlation, which makes sense too, right? I mean, the more experience you have, usually in the real world, the more money you would make in your career. So this is for one particular occupation. You're seeing all these different people, different points in their career, and they're making these different salary counts. Let's just try to eyeball a line of best fit. Now, we're not going to be able to get it exact, like I said in an earlier lecture. In fact, this actually involves calculus, but we can certainly try to just guess and see, like, is that a good line of best fit? Well, no, that looks silly, right? That one. It looks like it's going to kind of be over here, right? You can kind of eyeball it. I don't know. What do you think? You kind of want to have kind of the majority of points really close to you. Actually, that doesn't look so bad. Look at that. See, there's a bunch of points a little bit above, a bunch of points a little bit below. It really seems to kind of conform to that, doesn't it? Look good? I think it looks good. So let's just say that, okay, that'll be our line. That'll be our approximation to the line of best fit. I'm going to draw that in right now live. In what color should I use? I think I have to use this color. So I'm going to put it right exactly where we had it. That was really kind of neat. It was kind of amazingly close, I thought. Here we go. Yeah, that actually seems pretty good, right? Lots of data are either on or near it, and it kind of has a nice distribution. So I like this. So let's consider that as our approximation, our linear approximation to the data. So we have this great line, but let's see if we can represent this line algebraically. Okay, so here we go. And you know how to do that, of course. That we know how to do. We just need to find the y-intercept and the slope. So what's the y-intercept? Well, the y-intercept, you can see, just this is 20, this is 40, these are in thousands. So this is about 30, maybe a little above 30, so let's call it 31. This is just a rough approximation. So we'll say the y-intercept, which we usually denote as b, we'll say is 31. And what about the slope? Well, slope is just, rise over run. So let's pick the point right here roughly and the point right here roughly. So you go rise, that's going to be about 10 units over, and then the run is going to be 2, 4, 6. So it looks like 10 over 6. So the slope, which we usually write as m, would be 10 over 6, or 10/6, which is 5/3 after we simplify it. And so the equation of the line, and this, by the way, if you want to write this out, this is approximately 1.67, it's 1.666 forever. So the equation of the line would be y equals 1.67x, so y equals mx plus b plus 31. Because remember that a line, equation of a line, I'm going to remind you, y equals mx plus b. And so we see that the algebraic representation of the line is given like this, and now we can actually interpret it a little bit, right? So what does the y-intercept of 31 means? Well, it means that if you have no experience, that is what the line would tell us the salary is, which would mean, essentially, if you translate that, your initial or your starting salary would be around $31,000. Okay, so that's what that means. It means kind of starting salary in this case. What does the slope of 1.67 mean? How would we interpret that slope? What we would say is, for each additional year of experience you have, your salary would increase by around $1.67,000 or $1,670. So for every year experience, we would expect, the line tells us that we would expect the salary to rise by an extra $1,670. So you can actually make sense out of the algebraic formulation of this linear fit to this particular data set. So you can really actually think about data in a variety of ways. You can visualize it. You can visualize it geometrically, and you can even visualize it algebraically. And in both contexts, we extract more information from the data set. Absolutely wonderful to see the power and the pull of statistical thinking. I'll see you soon.
Okay, now you want to get the key objectives in your notes. And if you haven't done so already, make sure you get this information also in your notes.